A box of mass 15 kg is placed on a ramp. If the maximum angle to which the box can be raised without the box sliding down is 35 degrees, what is the minimum coefficient of static friction that would keep the box from sliding down? Now we have to find out the coefficient of static friction. Here the angle is given to us. Let us do the problem. Here the angle is 35 degrees. So this angle is also 35 degrees. And then the mass of this box is equal to 15 kg. And then this is Fn. And then this is Fg. And this is Fg perpendicular. And this is Fg parallel. And then as the box is sliding down, this is the F friction. Okay. Now let us write the forces. This is the free body diagram. Now we have to write the force equations. Let us write the force equation for the y direction. Sigma Fy is equal to Fn minus Fg perpendicular is equal to MAy. There is no motion along the y direction. Therefore, Ay is equal to 0. That implies Fn minus Fg perpendicular is equal to 0, or Fn is equal to Fg perpendicular. So Fg perpendicular is equal to mg cos theta, cos 35 here. And here the mass is equal to 15 kilograms, and then g is equal to 9.8. So this is equal to cos 35 degrees. Fn is equal to. Now F friction is equal to mu Fn. Mu k, I will write mu k Fn. So that is equal to, here we have to find out the mu k. So therefore this is equal to mu k times 15 times 9.8 times cos 35 degrees. Now we will write the x dimension forces. Sigma Fx is equal to Fg parallel minus F friction is equal to MAx. But the object is in static equilibrium, so Ax is equal to 0. That implies Fg parallel is equal to F friction. And Fg parallel is mg sine theta. That is equal to, here, this is mu k 15 into 9.8 into cos 35 degrees. Okay, so same thing I will write here. 15 into 9.8 into sine 35 degrees is equal to mu k times 15 into 9.8 into cos 35 degrees. Okay, so 15 into 9.8, 15 into 9.8 goes off. We are left with this one. So sine 35 divided by cos 35 is the mu k, or mu k is equal to tan 35 degrees. And tan 35 is equal to 0.7. So this is the value of coefficient of kinetic friction. Here the condition is the parallel component of the weight balances the frictional force. If we know this equation, then this is easy to find out the coefficient of kinetic friction. Hope this helps. Thank you. Bye-bye.